Special right triangles are something that you can do that is completely and totally mechanical. In other words, if you know what the rules are, you don't have to think. That's what makes them special right triangles, because in mathematics, something that requires no work, that's special. There are two kinds of special right triangles. One of them is an isosceles right triangle. There are only two ways I can present this as a question. First of all, it's isosceles, so we know that these are congruent. We also know from the base angle theorem that these two angles have to be congruent. They have to equal 45 degrees each, so sometimes these are called 45, 45, 90 triangles. But it's important to remember that they're isosceles because if I tell you what this side length is, it should require no thought at all to figure out what this side length is, because they're the same. Here, what's this side length? Well, if you remember, I said, let's pretend this is a square, a unit square, and we cut it in half so we have two congruent isosceles right triangles with a side length of 1, the leg length of 1. And I said, well, let's pretend we take two of them. And then we rearrange them. And I asked you, what is the area of this? If the area of this is 1 and the area of this is 1, and I'm using those four together to make this, what's the area of this? 2. And it's a square, which means that the side length here is the square root of 2. Because that's what square root means. It's the length of the side of a square that gives you the area of that number. So whatever this is going to be that number times the square root of 2. Now, let's say that I give you this. That's the only other way I can present this problem. I can give you the leg, or I can give you the hypotenuse. Remember, the hypotenuse is the side across from the right angle. Well, what happens here? C. Okay. If I know that C is the hypotenuse, then that means whatever this is, when I multiply it by square root of 2, I'm going to get this. So let's just say x times the square root of 2 is equal to this. So then we're going to find out what these are equal to. How do we do that? Well, first let's multiply both sides by square root of 2. Square root of 2 times square root of 2 is 2. Divide both sides by 2. And now I know that if this is C, this is square root of 2 over 2 times C. And I'm done. So now let's think about it in terms of how do you do a test? Oh, it's special right triangles. I'm going to look at the special right triangle. First thing I'm going to ask myself, is this a 45, 45, 90 right triangle? How can you tell? Well, it either says 45 in here somewhere, or it has this on it somewhere. If the answer is yes, then the next question is, was I given a leg, or was I given the hypotenuse? Whichever one you were given, you then look at your resource page and say, oh, I was given the leg, so I know the other leg is the same, and the hypotenuse is that number times the square root of 2, all done. Wait.
So the bottom is the hypotenuse?
Not always the bottom, right?
In this case.
No. The hypotenuse is always the side that is across from the 90-degree angle.
Okay, but then you gave us the hypotenuse.
I did here. I said this is going to be C.
Well,
Over here, I gave you the leg, right? And so then we knew this leg was going to be this, and we knew that the hypotenuse was going to be x times the square root of 2. Does that make sense?
yes.
Good. Okay. The other kind of right triangle that is a special right triangle is half an equilateral triangle. This side is equal to this side is equal to this side, and each one of these angles is 60 degrees. And if I cut it in half, and I have half of an equilateral triangle, this is a right angle, this is 30 degrees, this is 60 degrees. Angles and side lengths have this relationship. The longest side of a triangle is always across from the longest angle. And in a right triangle, that's the hypotenuse. So this is the hypotenuse. The shortest side is always the side across from the smallest angle. So this would be called the short leg, right? Because you got hypotenuse and legs. And this would be called the long leg. And the way you know is not by looking at the drawing, because the drawing may not be to scale. You look at the angle measurement. Okay? So for example, for this one here, well, which one's the long one and which one's the short one? I can almost say this was, these were equal. But if I say this is 30 degrees and this is 60 degrees, well, now this is the short leg, that's the long leg, that's the hypotenuse. Everybody with me on this? The hypotenuse is always the side across from the 90-degree angle. So there are 3 ways I can present this to you. I could give you the short leg. I could give you the hypotenuse. Or I could give you the long leg. That's it. It's only 3 ways I can do this. Here's what we know. Because this started out as an equilateral triangle, we know that the short leg over here is half of what this is, because this started out with all 3 sides being equal. So whatever this is, the hypotenuse is twice as big. And whatever the hypotenuse is, the short leg is half of that. Right? This is 30 degrees. This is 30 degrees. This is 30 degrees. This is 60 degrees. This is 60 degrees. And this is 60 degrees. Okay? Now the question is, what's this? Right, but how long is that going to be? Exactly. It's going to be this number right here times the square root of 3. And here, it's going to be this number times the square root of 3.
This is by the long leg? Or?
The long leg, right. If you're given the hypotenuse, you get the short leg is x over 2. The long leg will be x over 2 times square root of 3. All 3 of these are 30, 60, 90 triangles. All right. So here's the deal with this. What if I give you the long leg? Well, the long leg is going to be the short leg times the square root of 3. If I multiply both sides times the square root of 3, I get that. If I divide both sides by 3, I get that. And that tells me that if I know what this is right here, this is going to be that number times the square root of 3 over 3. And the hypotenuse is going to be twice as big. Take a look at this. The short leg, the long leg, the hypotenuse. I can give you this, I can give you this, or I can give you this. If I give you the short leg, the hypotenuse is 2 times as big. If I give you the hypotenuse, the short leg is half as big. Whatever the short leg is, the long leg is going to be that number times the square root of 3. And here we just figured out that if I give you the long leg, the short leg is the square root of 3 over 3 times that number. And the hypotenuse is 2 times the square root of 3 over 3 times that number. For the 45, 45, 90, you get a leg, you get a hypotenuse. If I give you the leg, the hypotenuse is square root of 2 times that number. If I give you the hypotenuse, the leg is square root of 2 over 2 times that number. This does not take up a whole lot of room on a resource page, but it means that if you have this on your resource page, when you get a special right triangle problem, all you have to do is say, question 1, is this 45, 45, 90, or is this 30, 60, 90? That tells you which one of these two to use. Then you say, what was I given? You find the x in that column for what you were given, and the other 2 entries give you the number you need to multiply it by to get the other 2 parts of the triangle. This is what I mean by you can do this in 30 seconds. This is the short leg. This is the hypotenuse, so it has to be twice as big. This is the long leg, so it has to be this times the square root of 3. All done. Yeah. This is the short leg. Not 8, 18. This has to be twice as big as this. This has to be this times the square root of 3. Okay, let's do this one. This is a 36. I'll show you all the answers in a minute. 30, 60, 90. I'm given the hypotenuse. The short leg has to be half of that. The long leg has to be the short leg times the square root of 3. All done. Yeah.
Would you write it as 13 times 13 to square root of
This
3 over 2?
This is equal to this. You can write it either way. Here, yeah.
Can you turn like the 13 into a decimal then?
Yeah, if you want to work harder, you can turn this into 6.5 square root of 3. But I was done here. Right? I mean, you can make this as hard as you want, but I was done when I got to here. Here, this is an equilateral triangle, but I'm being asked about this special right triangle over here, with the trick being the 15 is over here, but if it's an equilateral triangle, that means this is 15, right? And this is the hypotenuse, so this is half of that. And this is half of that times the square root of 3. All done.
Because it's from small to big.
This is a 30, 60, 90 triangle. This is the hypotenuse, it's 15. So the short leg has to be half of that. And the long leg has to be the short leg times the square root of 3. The deal is If I'm given this number on a 30, 60, 90 triangle, whatever this number is, when I divide it by 2, it gives me the length of the short leg. And whatever this number is, when I multiply it by square root of 3, I get the length of the long leg. That's what always is. This is the ugly one. The one across from 60 degrees is 15. That means the short leg is going to be 15 times the square root of 3 over 3, which you can reduce to 5 square root of 3. If this is 5 square root of 3, this is 10 square root of 3. All done. What's this? This is a square. This, they're all square root of 3. So that means this is square root of 3, this is square root of 3, this is square root of 3. That means that this is a special right triangle because it's 45, 45, 90. And if I know what the leg is, I know that the hypotenuse is the square root of 3 times the square root of 2, and that's equal to the square root of 6. Here's another square.
That was a 40, I'm sorry.
45, 45, 90. Right? Because it's a isosceles right triangle. Here too, I got isosceles right triangles all over the place. The leg is 5 square root of 2. The hypotenuse is going to be 5 square root of 2 times square root of 2, and that's 10. This last one, it's a 45, 45, 90. I'm given the hypotenuse. Multiply that by square root of 2 over 2, reduces to 3 square root of 2. That is the length of the sides, and I'm all done. Now, it's very, yeah, because it's an isosceles triangle. That's really easy for me, the math teacher, who's been doing this since there were dinosaurs walking on the face of the earth. So yeah, I can do this in 7 seconds flat. Will it take you a little longer? Of course it will. But if you have all of the information as to what to do,
You can do it.
uh-huh, that's the idea. Okay? If you make it more complicated, it will be more complicated, and there will be more ways to make mistakes. Yes?
The number 7, I don't know how you got 10.
Okay. I got a 45, 45, 90 degree triangle, right? Right angles here, and this is 5 square root of 2. Agreed? Okay. So I go over here. Oh, look. If I have the leg of a 45, 45, 90, I can multiply that number by the square root of 2 to get the hypotenuse. Okay. So, here. 5 square root of 2 times square root of 2. Well, square root of 2 times square root of 2 is 2. 5 times 2 is 10. Okay?